Ready? Okay, so these are our cross sections. These are, first of all, unless you're artsy, don't even try to graph these up. You all haven't really been graphing these, right? Like what figures they're making when they're rotation. Okay, on the cross sections, we are not rotating anything. The figure is just there, and we're dividing it up to how it tells us to divide it up. Okay, so there's not really any choices to be made about, oh, where's my radius? That is all made for you. They tell you where it is. They tell you what shape it is. Like, for example, this right here is in triangle shapes. And they tell you how to lay them out there, but the solid figure is just kind of sitting there, and then you get to divide it up. This shape looks kind of like a rhombus. Okay, there's some more triangles. So that's the difference. You've got a hunk of something and you're just dividing it up. Now, what's weird to me is you've got, like, just say you got this hunk of ham here. Okay, and sitting here and you're dividing it up into triangles. Okay, whatever. I'm just saying when I'm shut up. We don't care why you would. I'm caring that's what we're saying to do. Okay. To me, your triangles are going to go like this. They're going to go like this. So they're not going to be all laying in there nice and pretty like the discs, little circles, and the other little things are. So you got to be careful. On your handout, that's a separate sheet. I've drawn the picture so maybe some of you that appreciate that can visualize that. But again, you can be very methodical, and it's really okay. Okay, so here is the y equals x, radical x. So this is where you start. Y equals radical x right here. Okay. And y equals 0 is right here. Y equals 0. This there. All right, and then x equals 4 is right there. Okay. So you start out the same, and you say, all right, there's my shaded area clearly, okay? Now, what the difference is that they're going to actually use the word cross-section, so there's not going to be, wait, is it this, it's a washer, it's a cross-section. Those are your three choices for volume in Calc 1. Okay, they also tell you what shape they are. In this case, we have a square, okay? So this is what they look like when you divide them up. They're all different sizes. To me, that doesn't look like a square, but remember, it's kind of a 3D perspective, so sometimes that gets a little weird. Okay, and they also tell you that where they are. Okay, so you have all kinds of shapes. All right, how do we find the area of squares? Okay, you can be more specific. Squares. Length and width are the same people. Side squared. Okay, that's what I was going for. That we didn't need to make a distinction between length and width because they're the same. So whatever you want to call them. Okay. Side. Okay. All right. Now we go from area to volume. We just add, and this is what's kind of weird too. We just add the change in whatever for the. And you just kind of have to just say, okay, that doesn't make sense to me, but what is it for the height? Change in this case, if they're perpendicular to the x-axis, are we going to be, here's one right here. That's a square looking at you. All you're seeing is the width, though. Is it going to be changing x or changing y? Changing x. And that's the same, reason that we did, if it touches the x, it's going to be changing x. If it touches the y, when extended. But you don't have to make a decision or how do I want to do this because that's very specific. Yes.
So, sorry. So just for the square, where you just like add that
for any of them. To go from area to volume, you got to add this height, which is your change in x or change in y.
Why did we change x again for that one?
Because you hit the x.
Okay. But it was like.
But it's not. So don't go there. Don't go what if yet. Do that after we've done that, okay? I'm going to do this. All right. Okay. Okay, so here's my square. All right. This square right here, you're looking at it, it's right here. This piece right here is this. This piece is this, which is also this because it's a square. Okay, so what is that? You've done that a zillion times. Radical x minus 0. It's the same way we found the radius on the washers and the disc. Top minus bottom. Okay? So we take radical x and we square it and change in x. Now we're ready for an integration because we're going to put all those squares together. Okay? The boundary is still going to be of the shaded area from here to here in terms of x. What is it? 0 to 4 because that was y equal x equals 4. Very good. Okay. What's the square root of x squared? And that changes to dx. And we're good. We could do this one by hand, right? Probably quicker than we can. I'm going to bring my half out here. And 16 minus 0. So what is half of 16? 8. Now, you're going to want to throw pi in there when you need to. Please don't. It's a square. Square is nothing to pi. Pi's are not squared.
Your voice cracked. You were so nervous.
Do what?
Your voice cracked. You got so nervous.
Don't. Okay. I mean, the disk is pi because it's a circle. Pi are squared. The washers are circles also, and so they're pi. So be careful. You don't want to include a pi unless you have a circle involved. These are squares. Any questions? All right, we're going to do another one, same shape, but we're going to divide it up differently. Okay, so we got our y equals x, radical x again. We got x equals 4. Again, I should have pasted. And y equals 0, right? Oops. Okay, so we start out the same way with that shaded area. All right, now cross sections, perpendicular to y-axis, they're square again. All right, perpendicular to the y-axis. Okay, that doesn't mean they have to touch the y-axis. That means they're just going to go like this. This is my square. Okay? It's perpendicular, but it doesn't really touch. But that's okay. Okay? So this right here is my square. This is the same as this, which since it's a square, they're all the same. Okay? Now we're in terms of y, the same reason that we did it before. So we start with area of a square. Again is side squared. All right, volume, take the side squared times the height.
Do you always want us to write?
You don't have to. I'm just trying to be very methodical. All right, and then the height is going to change to change in y. We already determined that, but the same reason as it was always when it's the y-axis when extended, it's in terms of y. Okay, so who can tell me what my side is? Megan Holt? The side is from here to here, or from here to here, whichever one.
That's what I'm saying. Is I don't. It's not y-axis.
It needs a y. So y squared equals x. So 4 minus y squared.
That's what I'm saying.
Sounds good. That goes in here. Don't forget to square. That's one thing you all have done a great job. You haven't forgotten that square by and large. You've been doing that pretty well. Okay? Did I lose anybody? All right, let's change this. We're ready for an integration. I'm just going to leave it because I'm going to plug it in the calculator. Changing y, dy, we need some limits. We're doing y now, 0 to Here's the bottom, what's the top? Well, we knew this is x equals 4, so what's y? Y equals radical 4, so it's 2. 0 to 2. That point is 2, 4 up there. Or 4 2s rather. Yes. Say it again.
Like it says perpendicular. Like, could you do perpendicular instead of like x equals 4? And would that be y squared minus 4? Or do you just do?
They're not. I mean, that's the same thing. It is perpendicular to x equals 4.
Then how come
Because it's always right to left.
Did you do it to me?
Do what?
Did you do it to me?
Yes, I did. Okay. Plug it in your calculator, ladies. It seems weird that you wouldn't get the same answer. That's the weird thing about it. Yes?
And for these, would you like us to keep going with like fractions, even though there's no pi, or you know?
I don't care at all.
Okay.
I do not care. Throw it in there. What do we get?
256.15.
Okay. Now, this is the weird thing. Like, why aren't these the same? They're exactly the same area. But that's kind of the conundrum. I don't know why. So don't try not to think about it too much, because sometimes you're going to get the same answer, sometimes you're going to get different.
And normally you would have done that in terms of x, but we just did it in terms of y there because it told us to, right?
Yes, they will tell you to do that. And cross-section is very specific, and you don't ever have to make that decision. Okay? Any other questions? All right, let's try a new figure here. And we have a little sphere, yes. Okay, so you wouldn't be looking at this, you would be looking at this, so try not, that's just so you can see kind of what it's about, but I want to do it like you would attack it on homework problem. So calculate the volume of the solid with base R that has semicircular cross sections that are perpendicular to the y-axis. R is bounded by the circle x squared plus y squared equals 25. Okay, now if you were going to put this in your calculator, you would have to put like this. Okay? Because that's the only way that function is going to be there. So this is the, where's my y-axis? Right here. This is the top part. And this is the bottom part from your graph. Okay? Because that's a function.
Because
That's how we did it on the graph. Okay, wait, calm down. I wanted to get my picture in my graph clear. That's where I am right now. So just, yes, okay. You're good. Just hold that thought. Okay, so we have it in our graph. We have this, all right? Now everybody knows where these came from, right? Okay. Okay, so now we are going to draw semicircles that are perpendicular to the y-axis. Here's one drawn right here. Perpendicular to the y-axis. Okay? Now, this is a semicircle. It looks like this. Okay? This is the diameter of the semicircle, correct? Okay. Let's figure out now. Remember, we can put it here, we can put it here, we can put it here, we can put it anywhere. That's what, but it's like the tiny little protractors. They're all standing in there. Okay, here's one that you can kind of see. Okay, now how do we find the length of any of these guys? This is where I think you were going. It's this minus this, right? So now we've got to do, let's do this side. That's this. Okay? And this side is this. Okay? Is that where you were going? Is that why you thought you needed to go sideways? Yes, and you were right. This is just for graphing purposes. Okay? So, purple area of a semicircle. How do you find the area of a semicircle again? Very good. Okay. The area of a semicircle, volume of all the semicircles, 1/2 pi r squared h. H is going to change in y, because we're hitting that y-axis. Okay? All right, 1/2 pi r. All right. I need an r. This is my diameter. What's the difference between diameter and radius? Radius is half. Okay, so my diameter is purple minus orange. Okay? So what is that? Purple is root of 25 minus y squared. And what's orange? Oops. Negative root 25 minus y squared. Okay? Plus. What is that? Good. 2 roots. Okay, that's my diameter. What's my radius?
Radical 25.
One of those. That's right. Good job. Okay, that's the weirdest part.
Wait, does it always work out that it's just one of the values, or is it just coincidence for this one?
I mean, always means how many of these you're going to do, but yes, it will always be that way because you're trying the diameter, you're going to take half. Okay, anybody ready to stick that R? Did I lose anybody? Do you want to hear it again? Okay, so radical 25 minus y squared goes in here, and changing y goes here. Okay, we're ready for our integration. Oh, perfect. Equals. Okay, half pi is a constant, so I'm going to pull it out. What's radical 25 minus y squared?
25 minus y squared.
Okay. dy, now we have to figure out our limits. In terms of y, this way,
On the graph, it says
-5 to 5 works for me. It's your radius of 5, so there's a 5, there's a -5. Okay, there you go. You can plug it in. Actually, this is going to be even, right? So I'll just do it. Or you can plug it in. What's that? 275, 250, 250 over 3. All right. I'm going to put in place, but
because of the 1.5.
okay. I did the symmetry where I took 2 and just went from 0 to 5. Again, you're welcome to throw it in your calculator at this point if you want. Okay? Just don't, go crazy. We're going to do another isosceles right triangle next. Can't wait, can you? Early. The base of a certain solid is a plane region R enclosed by the x-axis and the curve y equals 1x squared. Okay.
1 minus x squared.
1 minus, yes, thank you. X-axis right here, and 1 minus x squared. Remember what that looks like?
Oh, it's the y-axis is that 1.
No.
It's got -1 and it opens upside down.
Oh, just kidding, you're right.
A +1 opens upside down.
I said the y-axis is that 1.
Oh, sorry, I was not.
I heard you murmuring that. Okay, well,
All right, so what's our area here? Right inside here. Okay, now we get cross sections that are perpendicular to the y-axis. So go ahead and draw one, perpendicular to the y-axis. Okay. And they're isosceles triangles. Isosceles right triangles, so they look like this. With this piece right here is the hypotenuse. Okay? This piece. Hypotenuse, line, and arc. So that's all dictated. You don't have to worry about that, but you just have to get it right. Okay. Isosceles right. Isosceles means two legs are the same, right? Those have to be the two. How do we find the area of an isosceles triangle? Right triangle. Okay? And the base and the height are the same, right? Because they're isosceles. So I'm going to just do B squared. So this is a B, this is a B. Okay? All right, now when you're looking at this right triangle, this right here, this piece right here is a hypotenuse. Okay? So, let's see. I guess we have to figure out what the hypotenuse is, and then we can figure out the base of it, right? So what's the hypotenuse? This is the hypotenuse. What is it? This to this. Yes, you would. Because it's got to be in terms of y anyway, right? All right. So our volume, when we get there, is going to be changing y. All right. So y minus 1 equals negative x squared. X squared equals negative y plus 1. So x equals, what's this piece?
radical negative y plus 1.
Okay. And this piece,
Negative radical negative y plus 1.
okay. Does that make sense, everybody? We have to do that with the circle before, now we're just doing it with the parabola. Okay. So, right to left, because the right is always bigger, so that's blue. The hypotenuse is the blue minus the purple, right? Okay, so what's the hypotenuse? Oops, I did that was supposed to be good. All right, that's the hypotenuse, which is right here. Negative 2. All right? But that's not what we need to find the area. Okay? Let me extend so it's not going to get so busy here. 2 negative y plus 1 b.
So I'm gonna do like 2 negative y plus 1 squared.
Equals.
B squared plus B squared.
Very good, Emma. Pythagorean theorem. You could also do the 45-45 bit if you remember it. Write the 2's out. Oops, I forgot to square. Sorry. Okay, so 2 Negative y plus 1 is b squared. So b is radical 2, I'm just going to throw that together, plus 2. Negative 2y plus 2. So we squared the 2, squared the radical, divided the 2 out. Who remembers the 45 relationship on the 45 right triangle? Remember, this is a leg, this was leg, radical 2. So if you'd have taken this and divided by radical 2, you'd have gotten that. Okay? It's finally distributed. I don't know why I didn't do that a long time ago, but anyway. Okay, any questions? All right, that's where we put that up here. Negative 2y plus 1 squared. Right? Thank you. Okay. Squared off. So then we don't have a radical anymore. Okay.
Where's your 2 go?
I don't know. I keep trying to lose it. All right, we're ready to integrate.
Could you go ahead and put that in there?
Sure. You mean like distribute the 1/2?
Yeah, do negative y plus 1.
Sure. And now we got to figure out our limits. Okay, does anybody need us to back up before we get too far into the integration here? Good. Okay, it's very detailed, but you know, if you do it, it's kind of the same process. All right, so looks like we're doing in terms of y, so certainly 0, right? What's the top y? 20. There you have your.
Why is it 0 to 1 if you are using both sides?
Well, because that's the bottom y and that's the top y. Yeah.
In terms of y,
Bottom, top. Y is this way. X is this way. And you can throw this in your calculator. I do not care.
it's 1.
Okay, for all that. It's a lousy 1/2. Sweet.
Maybe we get that.
Do we have now any more?
No.
Okay.
Can you get it?